Hello, everyone, and thank you for joining us today for part 1 of our high-flow bioretention webinar series, the advancement of bioretention in stormwater treatment. Before we start today's presentation, we would like to cover a few housekeeping matters that will ensure you have a good experience. We have placed all phones on mute to cut down on background noise and to ensure everyone can hear the presentation. At the conclusion of today's webinar, we will provide information on how to obtain PDH credit for today's presentation. Our webinar today is scheduled to last for 1 hour and will include a question and answer period. If you have a question, please type it in the question box at any time. Today's webinar will be presented by Tamara Mammon, Vaco Allen, and Alex McLeod. Tamara is the stormwater consultant for Northern LA. She has been with Contec since 2017 after graduating from Purdue University with a master's degree in engineering management, specializing in industrial engineering, and an undergraduate degree in agricultural and biological engineering with a minor in environmental and ecological engineering. Vaco Allen is the National Regulatory Director at Contec. Throughout his years of stormwater management experience, he has worked with regulatory and research groups charged with evaluating pollutant removal and operational performance of structural treatment systems. Alex McLeod is the Director of Stormwater Engineering and Biofiltration Product Management at Contec. He has worked in the stormwater industry for over 12 years as a product design engineer, engineering manager, and a product manager. Alex is a licensed professional engineer in the state of Maryland and has a degree in biological resource engineering from the University of Maryland. Now I'll turn the presentation over to Tamara to get us started.
Thanks, Jill. Hi all, my name is Tamara Mammon, and as was just stated, I'm the stormwater consultant for Northern Los Angeles, Ventura, and Kern counties. Today I have the privilege of starting off our presentation to speak about the biofiltration basics. So in specific, what is biofiltration and how does Contec's Filterra system fit within the biofiltration niche? After that, Vaco Allen will take over and discuss the proven performance of Filterra in comparison to traditional biofiltration. And finally, Alex McLeod will finish it off with some Filterra designs that will help you meet your low impact development requirements for your site. We would like to start off our Filterra webinar with a quick poll question. Please select the image on the, or please select the term on the right that you think best represents the image on the left.
I'll give you a couple minutes to look at the picture. And then here's our poll. Please select bioretention, biofiltration, rain garden, or bioswale. I'll give you some time now to mark your selections. And while you're doing that, I just want to let you know in the handouts section, we do have 2 handouts. We have our Stormwater Solutions brochure and our Filterra brochure. So if you have time, check those out while we're going through our presentation. I'll give you a couple more moments to mark your selections. And thank you all for participating. And here are our results. 33% say bioretention, 52% say biofiltration, 24% say rain garden, and 7% say bioswale.
Thanks, Jill. So the point we would like to make here is that a lot of these terms are used interchangeably depending on the region you live in. We encourage you to look at your local permits and technical guidance manuals to determine the appropriate terminology for your region. This may be dictated by the absence or presence of an underdrain in the system, but for the sake of this presentation, we will be using a lot of these terms interchangeably and wanted to make that denotation. So what is a bioretention or a biofiltration gallery? It is a pollutant control mechanism that incorporates physical, biological, and or living processes via vegetation to capture, immobilize, and treat harmful pollutants. Without biological processes provided by the plant, the unit will not be as efficient in nutrient removal and metal uptake and should be termed a media filter, which does not meet the LID requirements of many regions around the country. To further display where these physical and biological processes occur within the biofilters, we will talk through them step by step during the storm event. Physical filtration first occurs in the mulch layer, which is depicted by number 1 in this diagram. This is where heavy sediment and debris are captured and retained, and then finer treatment occurs in the media, which is depicted by number 2 in the diagram. Pollutants are trapped through physical impact with the media particle, whereas dissolved pollutants are also captured in the mulch and media through physical and chemical processes. The chemical makeup of the media allows for adsorption of pollutants, such as phosphorus, in the form of phosphates that are chemically attracted to the soil components via absorption. Dissolved metals are removed through cation exchange reactions within the mulch and media. Moving on to the biological processes, the plant introduces a diverse ecosystem to the filtration bed. After the storm subsides, microbes and other organisms housed in and around the plant roots biodegrade various pollutants captured in processes 1 and 2. This is depicted by number 3 in the diagram. Through this process, the pollutants are transformed into soluble forms that the plant can utilize. The act of uptaking these pollutants from the reaction sites in the media opens up that site for use the next time it rains. This renews the media capacity, allowing the plants to use the nutrients for growth and bioaccumulating the heavy metals, as seen in 4 and 5 on the diagram on the left. Really driving home the importance of vegetation, the plant is crucial to maintenance. The roots keep the pore space open in the media over time and provide long-term shelter, as well as an organic food source for organisms doing the heavy lifting and regenerating the media's capacity. As the plant grows, the roots facilitate a more robust ecosystem, which provides more uptake, as well as some of the evapotranspiration of the stormwater flowing through the system. It is a symbiotic relationship. We need the plant to facilitate the biological activity in the media and to renew the media in the system. The plant needs water and nutrients to grow. You cannot have one without the other. If the system contains no plant, or the plant does not interact with the area of the media through which the stormwater flows, the media regeneration cannot occur. Likewise, if the stormwater does not reach an elevation in the system for the plant to access it, the plant will not live. If the maintenance of the system is not performed, so in the case of Filterra, the removal and replacement of the media, the system will be in bypass and the water will not reach the plant. So in addition to the plant, what makes up conventional bioretention? Its media typically flows at 1 to 12 inches per hour, depending on your local jurisdiction or requirements. It can take up a decent portion of the drainage area for your site, and it's typically designed by an engineer, sourced and installed by the contractor, and maintained by the landscaping crew. Its basic components are mulch, soil, stone, under-drain piping, and plants. But how does Filterra bioretention differ from that of conventional bioretention? You still have the plant, mulch, media, stone, and underdrain. However, our soil is a proprietary media that's been engineered to flow at 100 to 175 inches per hour. What media infiltration rate we use will depend on the local jurisdiction the product is being installed at. Due to this higher media infiltration rate, the Filterra has a much smaller footprint than that of conventional biofiltration. This frees up a lot more usable land on site, which can be a game changer on sites where the cost of land is steep, like California. There's a lot of versatility to our units to accommodate fitting them in any site. Our most basic and cost-effective design is our offline unit. This can have a curb or a pipe inlet and requires the use of a diversion structure. If you cannot accommodate the use of a diversion structure, we would recommend using one of our internal bypass curb models or the peak diversion. The peak diversion are for those sites with a slightly higher peak storm event because it has an inlet chamber and an outlet chamber separated by an internal weir wall to increase the capacity of that internal bypass. If the owner or architect is looking for a more aesthetic option, we do have the Bioscape Vault. This still has a pick in place of precast, however, it's open top, so it's a little more pleasing to the eye. If no precast is desired whatsoever, you can pursue the Filterra Bioscape, which is essentially a Filterra in a lined trench. This unit is ideal for those areas that need multiple vaults or just a large media surface area. Both of our Bioscape vaults also have internal bypass capacity. Another benefit of the Filterra system is that you're getting a prepackaged design that just needs to be set and backfilled by the contractor for our typical vaults. Our media batches are rigorously tested and quality controlled to keep performance consistent versus media mixed on site by a contractor to meet an engineer spec. Once the site is 90% stabilized, they can call the numbers boarded up on the Filterra to complete the activation. At the time of the activation, you'll receive your first maintenance event. The first year of maintenance is included with our Filterra system. At this time, they'll ensure the proper installation of the tree. So we want to make sure that a lot of the soil from the plant's root ball isn't mixing in too much with our proprietary media. And we'll also place the top 3 inches of mulch and replace the tree grate. A secondary visit is performed about 6 months after that to check on the livelihood of the plant. We want to make sure that it is either being irrigated in dry areas or that it's seeing enough stormwater to help it thrive. At that time, we will remove any trash, debris, and the 3 inches of mulch and replace the 3 inches of mulch on top. After the first year, the unit should still be maintained every 6 months. The mulch can be sourced locally per our mulch spec, and there is no confined space entry needed to maintain our units. So virtually anybody should be able to do these. However, if the owner so wishes to, they can go on our website and get a quote from any of our third-party certified maintenance providers in their area. I will now be handing over the presentation to Vaco Allen to start our discussion on key benefit number 3 of the Filterra, which is its proven performance.
And while we're switching presenters, we've had a couple great questions come in, so I'll just ask them now. The first one is, can you place Filterra in a raised planter?
The Filterras can be placed above ground. They just require an additional structural calculation.
Thank you. And then one more question. Do you need to replace the media when you replace the mulch during maintenance?
Yeah, so piggybacking on the last one, you can also put a bioscape in a raised planter as long as it meets our certain requirements. And we actually have our media tested out 15 to 20 years, and it should not need to be replaced if the mulch is adequately and properly changed every 6 months to prevent any occlusion within the media.
Great, thanks Tamara. Vaco, take it away.
Great, thank you. Good morning, everyone. So yeah, we're going to talk about performance here for a few slides. It's been over 15 years since Filterra was initially conceived in a laboratory, and we've been testing it really since then, both in the lab and in the field. At this point, we have 6 independently verified full-scale field studies. And the purpose of those studies is mainly to evaluate the water quality performance of these systems. So typically, we're using automated sampling equipment to take flow-weighted influent and effluent concentrations from the systems, and we compare the event mean concentrations going in and out to assess the removal efficiency of the system or the load reduction. Very useful information, and we're continuing to collect it. We actually have a couple of studies planned for this next year. In addition, a couple of other things that we're looking at are the performance of the system over time. So we want to know how the aging of the system affects performance. So there are 3 sites on the East Coast that we've been monitoring for more than 8 years, monitoring for metals, nutrients, and TSS, and found that really the performance doesn't change over time. It's fairly steady and actually improves in some cases for some pollutants, especially as the plant roots grow and the system matures. We'll always be doing lab testing. Just to characterize the media, we'll talk about quality control a little bit later in my part of the presentation. But in some cases, particularly in New Jersey, there are very specific laboratory requirements that you must pass in order to get a regulatory approval. So we have done some lab testing there and for ETV in Canada as well, and we'll talk about that in a minute. And the last piece of testing that we have been conducting is hydraulic conductivity testing. So we have, about 10 years ago, we went out to 10 different sites that were anywhere from installed for about a month, with about a month since activation, to systems that have been installed for a few years and had not been maintained for up to 25 months. And we measured the hydraulic conductivity in all those different systems and found that the 140 inch per hour point was the lower 95th percentile confidence limit on the infiltration rates that we measured. So we could be pretty sure that using that 140 inch per hour infiltration rate would stand up even if maintenance was neglected a little bit. To be clear, we're not recommending that you do neglect it, but those things do happen occasionally. So you'll see that that rate is used in different places around the country. At the bottom is a few different screenshots of some of the testing that we've actually conducted, and reminding me to mention that we've tested these systems from the very small, like you see on the left, to the very large, like the Manchester stormwater system that you see there with all the 4 different Filterra cells in the second illustration. So at this point, the premier field monitoring protocol is the Washington Department of Ecology TAPE program. They've established a technology assessment protocol, Ecology, otherwise known as TAPE, which is really a guide for evaluation of stormwater treatment systems in the field. And the Washington Department of Ecology has set up some very specific performance standards that must be met in order for treatment systems to be used in that state. And if systems are tested following the protocol and meet those standards, then the ultimate goal or endpoint of the program is to get a general use level designation for the technology in the state for the specific pollutants. There are pilot and conditional use level designations available as well for technologies that maybe have a little bit of lab data or a little bit of field data, but haven't quite followed the TAPE requirements. So I bring that up just because I want to reinforce that it's important to look for general use level designations from the Washington Department of Ecology to really indicate that a technology has made it all the way through the testing process and has been approved. There is a link at the bottom of the slide here, and you can Google TAPE and ecology and stormwater, and I'm sure find the same resources. Sprinkled throughout this presentation, you'll see a few resources or links. So when we distribute these slides after the fact, then you can follow those up. So here are the different treatment goals or performance goals that Ecology uses. And you can see that the Filterra system is approved for basic dissolved phosphorus and oil and grease treatment. We've actually been through the program 3 different times at 3 different locations to get these approvals. One thing that's interesting to note is for the performance goals, there are influent concentration ranges of interest. The reason that those are set, for example, for TSS, we're looking at basically between 20 and 200 milligrams per liter. The reason that those are set is so that the data that's collected is relatively representative of typical stormwater conditions. So in other words, we don't want to, for TSS, for example, be sampling water that's 1,000 or 2,000 milligrams per liter coming in, because that just is kind of an outlier or in the very high upper range of what you might expect for TSS concentrations. And it's actually much easier usually to get high removal efficiencies. So these influent concentrations are somewhat constrained to be to focus the research into typical conditions. In the laboratory, the premier testing program is the New Jersey Department of Environmental Protection. Here they have a lab-based testing protocol that requires the use of a manufactured silica product with an average particle diameter of 75 microns, and 80% of those particles by mass are greater than 8 microns. So the implication or the assumption here is that if you're able to remove 80% of this TSS sample in the lab setting, then you're probably removing particles that are about 8 microns and larger. Now, this program is actually run as a partnership between NJCAT and NJDEP. So NJCAT is the New Jersey Corporation for Advanced Technology. They essentially are a verification body. So they will look at the testing that is conducted, and they will verify whether or not it meets the protocol that was set out for the test. and they will verify whether or not the test data that was collected is accurate. And NJDEP will then certify the technology if the testing protocol that was used is their laboratory testing protocol, and if the performance meets their goal of 80% TSS removal. Now, it's important to note that NJCAT will also verify test results that are collected from other protocols. So you may see some stormwater technologies that have NJCAT verification reports, but not NJDEP certifications for those same tests because they were conducted under a different protocol. So just be aware of that. So the Filterra has been through the NJDEP program. The standard Filterra system is approved. It's verified and certified at 140 inches per hour. And during those tests, we also assess mass load capacity with that same TSS surrogate. And the system achieved a 20 pound per square foot mass load capacity in those tests. Pretty excellent. We also sent the Filterra through in a slightly different configuration with a shallower media bed, the Filterra HC, or high capacity. That system passed the 80% TSS removal test at 300 inches per hour and achieved not quite as good a mass load capacity, but still solid at 15 pounds per square foot. At this point, this is a design that we're really just using in New Jersey. One of the reasons that we can do that is that New Jersey has a relatively large design storm. And so the proportion of the Filterra system as compared to the drainage area that it's treating is not really out of line with what we see in a lot of the rest of the country, where they have smaller design storms and we're using lower design infiltration rates. So we're going to look at a bunch of Filterra data here for the next few minutes, and I tried to present it in interesting ways that are also visually appealing here because we have this presentation to share together. So now one of the questions that we often get is, how does the design hydraulic loading rate or design infiltration rate, kind of use those terms interchangeably here, how does that affect the performance of the system? And the graph here on the right gives us an answer to that. The graph on the right, you can see that we have, I can get my cursor to work, there it is. This blue line is the line where at an influent concentration where you have on the x-axis here, removal efficiency on the y-axis. If you have 20 milligrams per liter coming out at various influent concentrations, you would land exactly on this blue line. So for example, if you're at 100 milligrams per liter influent and 80% removal, you would be at 20 milligrams per liter right on the line. So all the data points above the line are less than 20 milligrams per liter coming out, and anything below the line would be greater than 20 milligrams per liter. This is a lines of comparative performance analysis type approach that we can thank Gary Minton for developing 15 plus years ago as well. So the thing that's really interesting here, though, is that all the data kind of stacks up on top of each other. Whether you're at 50 or 175 inches per hour or somewhere in between, there really isn't a discernible trend in terms of the performance, in terms of the effluent quality of the system at those different flow rates. The reason for that is a couple fold. One is that the Filterra media is really the same, whether you're sizing at 50 or 150 or 175. The other is that there isn't a flow control downstream of the media. So the water flows through the media really at the characteristic rate of the media based on its hydraulic conductivity. What the design hydraulic loading rate really does affect, though, is the proportion of the system size in relationship to the contributing drainage area, and also the local design storm magnitude impacts that ratio. So in other words, the higher your hydraulic loading rate, the higher your design infiltration rate, the smaller your system is going to be, and the more loading you probably are going to see on a per square foot area on any given site. So for that reason, we don't use that 300 inches per hour, even though we do have the lab verification there, except in very rare circumstances where we have high local design storm intensities. And typically we're sizing in the 100, 140 inch per hour range. Another way to look at data comes from the International Stormwater BMP database. And if you haven't checked out this report already, I would definitely encourage you to. It came out at the end of 2020, and it gives summary statistics for a number of different treatment systems and most pollutants that you might be interested in removing for stormwater. So in addition to the statistics that we'll look at in just a second, there's some very good narrative descriptions of functionality, unit processes of different BMPs, and also what it takes to remove some of these difficult to remove pollutants. A few things that are different in this summary report from previous reports. I have highlighted high rate biofiltration here. This is a new category. Previously, they had lumped all manufactured devices together into one category, which literally included everything from Filterra to catch basin inserts. Now they've broken them out. So we have high rate biofiltration as a separate category. And it turns out that all the high rate biofiltration data is Filterra data. So there are 6 studies that are entered into the BMP database. They've also broken out bioretention into finer categories, with grass swale and grass strip as separate categories as well. So the way this data is set up in the database report here, they use box and whisker plots. And I'm going to give you a super fast crash course on how to read these things, because there's really a lot of information here. So they're influent and effluent concentrations that we're looking at here for data pairs. So data for water coming in and going out of a system. I think you can see my cursor. So we'll look at high rate biofiltration here. Each of these boxes here is set up in quartiles. The middle of this little notch here is the median point for the concentration. The upper part of the box is a 75th percentile, and the lower part of the box is a 25th percentile. Well, another important thing to look at is the little notch here. The little notch represents the 95th percentile confidence limits for the mean, for the median, sorry. And the dot there that is in the middle of the box roughly is the mean. So you can see very quickly whether those boxes are lined up, and in particular whether those 95th percentile confidence limits are lined up by noting whether the notches are overlapping or not. So in this case, it's maybe not super interesting, but we have TSS for high rate biofiltration and bioretention, both highlighted here. And we can see that there is a significant drop from influent to effluent, and those 95% confidence limits are not overlapping. So that is truly a statistically significant difference. And in fact, most BMPs actually work pretty well for suspended solids here. It's a little bit interesting when you start to look at nutrients. So here again, we have high rate biofiltration, which is otherwise known as Filterra here, because those are all the data points that are in this data set. And the means don't overlap, or sorry, the confidence limits don't overlap. So we can see that there is a significant reduction for Filterra when it comes to phosphorus. For bioswales, grass strips, grass swales, and bioretention, there is a significant difference as well, but it's in the wrong direction. It's actually a statistically significant increase in phosphorus concentration going from influent to effluent. Now, the reason for this is that many systems are using compost, or even some of the topsoil blends that are used have leachable nutrients in them. And when we're sending water through, especially in the first few years of operation, oftentimes the effluent concentration is actually higher than the influent concentration. We don't have that same issue with Filterra, really on purpose. We chose to not use compost or other organic amendments that have leachable qualities. So that's where performance really starts to diverge. And I'm not going to go through all the other plots there, but I would encourage you to go back and look at that report, and it's quite fascinating. Another way we're going to look at data here for a few minutes is moving window bootstrap plots. And that's kind of a mouthful, and you'll see what I mean in the next slide. But before I did that, I just wanted to at least throw up this slide here, and you can follow up afterwards and look at the data sources that we're using here. We're literally taking all the Filterra data that we have and putting it in these graphs, and we're querying the International BMP database to get all of the bioretention with underdrain studies from it. We've also added 4 additional studies that are not in the BMP database, but that are of systems of a similar design and proportion relative to the drainage area that are typical in most places. So I think these plots are very informative and easy to look at as well. So what we have here is a influent on, let's see if I can get my cursor to work again. Here we go. Yes, influent on the x-axis, effluent on the y-axis. So this blue line is basically the line of no change. Anything above the blue line is an export event. Anything below the blue line is a removal event. So all these little data points are actual storms or data pairs. You can see we have 176 here for TSS for Filterra and 354 for conventional biofiltration. A little bit hard to see on this graph, but perhaps you can look out in this range and see that there's a red line that is the expected median at effluent concentration at the corresponding influent concentration. And the dashed lines above and below that are the 95% confidence limits for that pollutant for the effluent concentration. So we can see that whether you're at 200 milligrams per liter or 400 milligrams per liter coming in, you're going to have a very low TSS effluent concentration, somewhere in the 5 to say 20 or so milligram per liter range for both technologies. Both very good. Again, things get quite a bit more interesting when you look at phosphorus. Here we have Filterra bioretention. The data is quite tightly grouped, and we do have a couple of export events out of 146, but for the most part, we are seeing removal in each event. That contrasts with conventional bioretention, which you can see has a lot of scatter and even most data points above the line of no change, meaning export at these lower concentrations. And it is typical that we see, you can tell by the scattering of the blue triangles there, that we see most of our data here down in this lower concentration range, where it's kind of a crapshoot whether you're going to get removal or export from conventional systems. So we're going through these kind of fast, but these are really kind of a stand back and squint type of chart where you can really get a feel for the trends pretty quickly. And we see the trends kind of continuing here with nitrogen. So looking at nitrogen, Filterra more consistently is having removal events as opposed to export events, and a little bit broader confidence intervals here because we have less data, only 34 data pairs here for Filterra. But you can see that performance basically improves as influent concentration increases. Shifting now to metals, we'll look at zinc first and then copper. So for both systems, they're pretty good at zinc removal. Really, we're looking at micrograms per liter instead of milligrams per liter now. As concentrations get up in the 1 to 200 range, we're seeing significant removal, in the 60, 70, 80, 90% range. And the effluent concentrations are quite low as well, in that 50 microgram per liter range. A little bit better here for conventional bioretention on average, although if you took these confidence limits that are indicated by the dashed lines and plotted them on the same graph, you would see that they're overlapping. So there's not a statistically significant difference between effluent concentrations that you would expect from a Filterra or a conventional bioretention system. And the last one we'll look at here is copper. And these are very similar plots as well. Basically, when you send stormwater through up to a couple feet of filter media, you're going to get most of your metals removed. And we see that here for both copper and zinc. Both systems performing quite well. There is a bit more scatter here, as you can see, with conventional bioretention. Again, some of the media composition challenges, just in terms of quality control, are probably to blame there, where depending on the compost feed source, for example, or even some of the sand that's used, there can be copper concentrations there that can be exported. So I hope that you've enjoyed that really rapid cruise through test data there. And one of the questions that we often get is, how can you pull off such high removal efficiencies at such a high hydraulic loading rate or high infiltration rates compared to the, say, 1 to 12 or so inch per hour rates that we're seeing with conventional systems? Well, the answer is really first by design and by engineering. Our media is created to limit or eliminate the possibility of having leachable nutrient concentrations. We also have a slightly coarser media than a lot of other conventional medias, but the real answer is the quality control aspect. We run over 20 tests on the different component parts of our media, and then when we blend it together, we also test that media. And in both cases, we have both performance specifications that have to be met and physical specifications. So we're measuring things like the hydraulic capacity of the media, as well as the physical characteristics like the particle size distribution and those sorts of things. So all of our media is identifiable by the batch and traceable back to the components that make it up. So if we ever have an issue, we can go back and identify where it came from and can correct it. And we've been doing this a long time, 15, 20 years now. So we have our media production and QC processes down extremely tight. So that's how we're able to consistently get these high flow rates. The other question that we often get after we go through all the performance data is, well, how does this fit into a low impact development application? Where maybe runoff reduction and volume control is also a part of the equation. And to talk about that, I'm going to shift over to Alex McLeod. Thank you.
Great, and while we're switching, I'll just ask a couple questions that have come in. We've had some really great questions, and just a reminder, type a question in the box at any time and I will ask it. Our first question is, does TAPE acceptance translate to acceptance outside of Washington, and are there similar programs in other states?
Yes, yes and yes. The first one, yes, but not in all cases. There are more than a dozen different jurisdictions around the country that refer directly back to TAPE in a formal way. So that might mean in their stormwater manual, they may say you must have 80% TSS removal, for example. And the way that you need to demonstrate that is to have a general use level designation for basic treatment from the Washington Department of Ecology. Or some cases they'll require phosphorus removal and say you must have a general use level designation from Ecology. So that is pretty common. And I would say that there's probably 50 or more other places that don't have a formal reference, but they will allow or accept TAPE approval. I'm sorry, the second part of that question.
Are there similar programs in other states?
Yes, there are a few other testing programs, like Sacramento Stormwater Quality Partnership, for example, has a field monitoring program. They're usually fairly similar in that they require field sampling and automatic samplers and event mean concentrations for the influent and effluent. Usually where there are other programs that exist, the TAPE program is as good or better. So those other programs will also allow Filterra data, or sorry, TAPE data.
Thank you. Our next question is, for California, is this system considered a full trash capture device, or does it require an additional pre-treatment trash capture device?
Yeah, that's a good question. So yes, it would be considered a full trash capture system, assuming that it's sized for the 1 year, 1 hour peak storm event. A lot of times the design storm that we're using for water quality, not for trash, is smaller than for the peak 1 hour design event, which is a trash design storm. So we need to be careful of that. But assuming that it's sized correctly, it fits under the category of bioretention, which is a multi-benefit treatment BMP and is approved as a full capture device in California.
Thank you. One more question. Is there a bypass inflow in case of clogging?
Yeah, so we make sure that our bypass is upstream of our media or external to the media bed, because we don't want to have runoff, say worst case scenario, the system does get plugged up due to lack of maintenance or some other issue. We don't want all the high flows to be running through the media bed to the outlet, because then you could scour things out. So we make sure that we have an upstream or an offline, I should say, bypass. Oftentimes this is just flow continuing along the curb line to another inlet that's downstream. That's the most common configuration. And there are many other configurations that we could look at if someone has a more particular site issue or constraint that they want to look at.
Well, thank you, Vaco. Now I'll turn it over to Alex McLeod to continue the presentation.
All right. Thanks, Jill. Thanks, Vaco. As Vaco just described, Filterra is capable of consistent and really good pollutant removal results. This allows it to fit into a wide range of stormwater treatment applications. However, Filterra is really unique in that it can be designed to meet many different low impact development or green infrastructure goals as well, places where other traditional bioretention practices are often considered. I'd like to take some time to review several design examples that apply the Filterra to these LID goals. But before that, let's do a quick review on LID. As most of you are probably aware, LID regulations and guidance can vary a lot depending on your regulatory requirements. But there are really three main pillars of LID that are found in practically every LID guidance manual. Number one, treatment at the source. Essentially, this means you want to prevent water from leaving the immediate drainage area that it runs off of. You want to minimize it flowing through long pipe networks to reach treatment and detention devices downstream. Number two, use of natural processes for treatment. LID encourages the use of plants and soil to provide stormwater filtration and infiltration and meet the in general treatment and storage requirements on your site. And number three, runoff reduction. Essentially, this is one of the most important ones, and it's focused on minimizing and in many cases completely eliminating the volume of water that ever leaves the site. So how can Filterra be applied to help you with these goals? In this first example from Toledo, Ohio, the designers were interested in implementing LID practices throughout the site. They also wanted to improve aesthetics. Additionally, since this was a renewal of an older hospital site, there was a lot of old existing infrastructure that needed to be tied into, so space and depth was extremely limited. The designers actually elected to use Filterra due to both its shallow design and the LID treatment benefits that it provides. They liked the idea of being able to use an innovative planted system that aligned with the other landscaping on the site. To meet the LID goals, they used 12 different Filterra systems that were scattered throughout the project that provided the decentralized direct treatment at the source the LID guidance prefers. You can see two of them here in the foreground of the photo on the slide, as well as a third one that's further back in between the two crosswalk signs you can see in the background of the photo. This project was actually installed in 2016. The systems are still doing pretty well. This slide shows an example plan layout showing several decentralized Filterra units treating a large parking lot. The offline configuration shown here incorporates a standard catch basin downstream of each system for bypass. Tamara got into the details on this type of configuration a little bit earlier in the slideshow. Not only is this the most cost-effective Filterra configuration, but it is also ideal for retrofits, since the existing catch basins and infrastructure in many cases can remain in place and not have to be disrupted. For the next few case studies, I really like to focus on how we can combine Filterra with other runoff reduction and volume control practices to help you achieve your LID goals. The Campus Walk project shown here, located in Virginia, combines a permeable pavement with Filterra. Permeable pavements do a great job of infiltrating water, but they don't really do a whole lot for treatment of pollutants and debris. Many times these pollutants remain on the surface and ultimately end up flowing downstream. Utilizing the Filterra is an intermediate step between the pavement and the bypass, allows these pollutants to be captured. In addition, the pavement underdrains can be discharged into the Filterra system, as you can see in the graphic in the upper left. This ensures the full treatment volume is managed even in cases where soil filtration rates may be decreased. This could be due to things like high water tables, saturation from back-to-back storms, or even lack of maintenance of the permeable pavement system. This project was installed in 2013. On the Robertson Ranch project shown here, the developer actually approached us. This is a large high-end home community in Southern California. The site had originally been designed with several above-ground infiltration basins scattered throughout the neighborhood. The developer was very concerned about aesthetics and really standing water potentially reducing the value of some of the homes that were located near the systems. Instead, Filterra systems were designed to provide the biological treatment component of the LID design requirements. The smaller footprint made it feasible for the developer to get a lot of the land back for other purposes. For this project, we actually developed the Filterra Bioscape Vault product. This is the open-top, more aesthetically pleasing variant of Filterra you see here in the photo. It provides a solution that was much more integrated into the surrounding landscape. Infiltration was then provided downstream using underground detention solutions. This allowed the remaining land surface areas around the systems to be utilized for value-added amenities. In this case, the playground you see in the background of the photo. Out of the 22 systems that were installed on this project back in 2017, the developer got a whole bunch of different opportunities to implement different amenities on site, including walking trails, benches, and numerous other features. I'd like to spend a little bit of time talking about the options that Contec can help you with when considering downstream underground infiltration that you're pairing with the Filterra system. Contec provides several different products that can be used in this application, shown here on the slide. One, our corrugated metal pipe detention systems. Number two, our Duramax detention systems, which is our highly durable steel reinforced polyethylene pipe. Number three, our ChamberMax product, which is very applicable for smaller, low cover designs. And then finally, our concrete arch detention system, TerryArch. In this example layout showing this type of design, you can see a peak diversion Filterra collecting both runoff from the curb as well as an inlet pipe, combined with a small ChamberMax system to meet the runoff reduction requirements. In most cases, with a Filterra drainage area being, in the range of somewhere between 1/4 and 1 acre, you're only going to need a few ChamberMax chambers to meet the requirements of the runoff reduction volumes. So the use of the installation of these systems ends up being very quick and easy. You can usually do it at the same time as the installation of the Filterra. And again, don't forget that utilizing an underground system like this allows you to get all that surface land back for other uses. In our last case study here, looking at the combination of Filterra with volume control and other runoff reduction practices, I'd like to talk about the Crosstone Commons project in Middletown, Maryland. On this project, several Filterra bioscape systems were integrated within larger storage basins. You can see that in the photo here. The Filterra is in the foreground, which is installed within a much larger grassed basin. Filterra Bioscape is another variant of the open-top Filterra, but it doesn't include a vault. Filterra Bioscape can be installed directly into the ground or really any other site-constructed container. Originally for this project, the entire basin, that whole area, comprising the Filterra and the grassed area, was designed as a traditional bioretention system. Redesigning this with Filterra allowed for a substantially smaller maintenance footprint because the area behind the Filterra really only requires mowing. Since the Filterra Bioscape is typically designed without any barriers at the bottom, this entire basin, including the Filterra area, can also infiltrate, providing an additional benefit in meeting runoff reduction requirements. The example layout on this next slide shows or illustrates this type of design. It does show a precast Filterra, but as you saw in the prior case study, this can also be applied to Filterra Bioscape or really any other configuration of Filterra. Volume storage can be combined upstream or downstream of the Filterra system, as you've seen in some of the previous slides, and you can utilize both traditional basins as well as manufactured detention and retention products, depending on your local requirements or your site constraints. We can help you with configuring the proper layout, elevations, and really any other layout constraints you may be dealing with when orienting the Filterra with one of these types of systems. In our last case study, Riverwatch on the James, I'd like to focus on tree cover. Aesthetics is a concern in stormwater, especially in areas where LID is a focus, because it draws positive attention to the system and really it contributes to knowing how well the system's functioning. If the plants are healthy, that's a good indicator that stormwater is flowing properly through the system. On the other hand, unhealthy vegetation can indicate problems like lack of maintenance, clogging, or improper design. In other words, water not reaching the biofiltration component of the system. Tree cover is becoming a big part of meeting LID goals. It improves site aesthetics, reduces the heat island effect, and established bigger trees provide the largest potential for evapotranspiration, which is one factor in runoff reduction. Plants are a critical part of treating stormwater in a biofiltration system like Filterra. Therefore, we provide several different options with the Filterra system to allow for the use of larger street trees up to 60 feet in mature height with our street tree Filterra configuration. This is in comparison to the 20 to 30 foot maximum mature tree height in our standard Filterra units. The project shown here is located in a neighborhood that overlooks a historic river. The designers wanted to maintain the historic feel of the community and have larger trees along the road. They use 5 Filterra systems with much larger trees than we would normally put in a standard unit to match the others on the site. This project was actually installed back in 2008. However, the photo here was taken in 2019, showing the systems still functioning and looking very great after 11 years in the ground. Again, the layout example here on this next slide shows the street tree Filterra configuration. This configuration includes a much deeper media profile, as well as optional side openings that allow root penetration and really facilitate the use of the larger tree species. This configuration can be combined with any of the other options for storage and runoff reduction that we've shown earlier on in the presentation. I'd like to thank everybody for your time today. We hope this webinar has given you a clearer picture of how you can be confident in incorporating high-flow bioretention solutions into your LID designs. We've now got a few minutes left here for a few questions. Thanks, everyone.
That's right. If you have a question, please type it in the box and I will ask it at this time. First question is, what is the advantage that open top vault versus Bioscape with no vault?
I'll take that one. The main benefit of the Bioscape Vault is that everything comes out prepackaged. It's ideal for smaller systems in the range of typical LID designs where you're talking about treating maybe a quarter acre up to maybe an acre or a little bit over. You don't have to worry about any kind of on-site installation, collecting all of the different components on site, ensuring they're protected during construction. All of that is delivered prefabricated, pre-protected in the Bioscape Vault. So it gets set in the ground with one pick. A regular Filterra Bioscape without the vault is ideal for larger systems where it's impossible to put it in a vault or where aesthetic or site constraints dictate something other than a precast vault.
Thank you, Alex. Our next question is, can the Filterra media be removed, cleaned, and reused, or is disposal the only option, assuming reuse would be at a different site?
We typically don't recommend that. You know, in most cases, the Filterra media will last in its original application, as Tamara mentioned earlier, for 15 plus years. At that point, you know, it may require remediation, but if you were in a situation where you wanted to remove a unit completely and relocate it to another site, I would be concerned about how the media was handled in the process. Is there contamination? Could there be contamination in the truck or the container that's being used to handle the product? It would probably be best to just replace the media if it was the whole system was being relocated.
Thank you, Alex. Does the fact that the plant is in a vault stunt the plant's growth?
It potentially can. So I've talked to a lot of plant specialists and arborists and different folks throughout the industry on this over the last 7 years, since I've been involved in the product. And in most cases, their response has been an overwhelming, it's not going to hurt the plant in a way that it's not going to grow, but it could mean that the plant doesn't reach its full mature height if it's in a much smaller container. Obviously, if it's in a really large Filterra vault, it's probably not going to be a big deal at all. But in some of the smaller ones, you know, if you're going to put a 20-foot tall mature height tree in a 4x4 Filterra, it may not reach 20 to 30 feet at that point. But we have not seen major issues with trees not doing well even in the smaller units. And we always have the Filterra street tree option that I described there at the end that does have root penetrations to allow tree roots to escape the vault.
Thank you, Alex. Is there a special mulch that has to be used?
We have a spec that we can provide that gives guidance on what types of mulch to look for. We look for mulches that come in a certain size range. You obviously don't want really small mulch particles because they won't allow much water through, but you don't want giant chunks either because they're not going to provide a very good level of pretreatment. We also look for mulches in wood products that don't typically float. You want the mulch to stay in place on top of the system. And then you want mulches that are not made of recycled furniture and other waste materials. You really want to look for mulches that are made from tree species, like fresh cut, you know, tree species and waste.
Thank you. Is the purpose of the mulch to prevent short circuiting through the filter media by concentrated flows? For example, mulch acts as a flow spreader to prevent water making a preferred path through the media.
The main purpose of the mulch is for pretreatment. So the mulch captures a lot of the heavier debris and sediment to help prevent it from making its way down into the media. We do provide flow dispersion and energy dissipation stones in the entryway of every system to help prevent scour and help water spread out evenly over the system. However, given the size of the Filterra system, typically spreading water out is not a major concern unless you get into some of the larger Filterra bioscape systems.
Can the owner change the mulch, or does Contech have to do it?
Somebody else want to take this one? I can take it, but
Yeah, I can take it. The owner can change the mulch as long as they follow our spec to source the mulch. They just have to remove the trash debris mulch and replace it. They can also contact any of our third-party certified maintenance providers that you can find on their website in our area for a quote.
Good to note too that we would provide the first year of maintenance. So that includes the activation of the system and then a year of maintenance after that. Part of the purpose there is that we want to make sure that the tree goes in right, that it's healthy, and we get a little bit of a, babysitting, if you will, to make sure that the system is operating right over that first year.
Thank you. Our next question is, in Maryland, pre-treatment is required to treat the first flush of runoff before it reaches the filter media. How is this handled in a Filterra system?
So we offer in Maryland a special design for Filterra called the Filterra Sedimentation Chamber that incorporates a pretreatment bay and meets the Maryland requirements. We also have approval to treat the full ESD volume by incorporating a storage component to the system as well.
Thank you. Can you use any particular type of plant or trees in the Filterra system?
For the most part, yes. There are some limitations. So we provide plant lists on our website that have a wide range of different species that we recommend in various areas. It's due to obviously the hardiness zone, making sure the plant can be grown in that area to begin with. It's also based on availability. We found that there's certain species that are just much more available throughout the year everywhere than others. But if you want something that's not on that list, you can ask. We can take a look at it. We're going to look for things like growth pattern. Do the roots grow wild and up out of the soil? We've had certain species that have done that. We would avoid those. We want species that don't have a high water demand, because obviously this is a flow-through system like every bioretention system. It does not stay wet forever. So you want plants that are capable of growing in soils like the Filterra media, and then we look for availability, making sure that we can actually get the plant in the area where you are requesting it.
How should the used mulch be disposed of? Is it considered hazardous?
We have not had any issues that I'm aware of where that's been the case. I would suggest that you check with your local maintenance companies in your area. It could potentially be regulated like any other stormwater waste material from any filter or hydrodynamic separator type unit. Vaco, I don't know if you have any more details on that.
No, that's right. I mean, typically you're going to dispose of it in the same way that you would if you're, pumping out catch basins or any other stormwater solids. And to be a hazardous waste, you would need to have some kind of a, spill or other issue. It's usually not going to happen from stormwater unless you're in an odd industrial application, which we don't usually use these systems in.
Well, thank you, Vaco and Tamara and Alex, and thank you everyone for participating in today's webinar. If your question was not answered, a Contech representative will reach out to you with a response. A brief survey will appear once we conclude the webinar. Please complete the short survey to receive your PDH credit. A follow-up email will be sent that will include a link with instructions on how to download your PDH certificate and also a link on how to register for Part 2, the current state of bioretention research, on April 21st. That concludes today's webinar. Thank you again for joining us and have a great day.
Thank you.